80 of which function?
A dx.
Exactly, this one. 275 minus 1.25x. Awesome. Minus always this product. 14,000. What about the producer surplus? And then we'll calculate. But let's establish the producer surplus as well. And then we'll calculate both. How do I start the producer surplus?
14,000.
Exactly, very good. Minus this time. It has to be the same from 0 to 80, but from the supply, because the supply goes with the producer. The demand goes with the consumer. From this one, 135 plus 0.5x dx. Exactly. And we're going to determine this. Allow me to calculate them quickly with a calculator so we can move on to another example, because now we know how to determine this. Would you agree, or you want me to show any of them or both? You choose. What will be the best for you? I'll do what you want me to do. So is it okay to do them with a calculator then?
Yes.
Okay, so we'll put them in the calculator. So we will have the integral from 0 to 80, from the demand, 275 minus 1.25x, of course dx, and then minus the 14,000. Okay, so the answer is 4,000, of course dollars. The other one will be 14,000 minus the integral from 0 to 80 from the other function, not the same, from the supply function plus 0.5x and dx, 1,600. Now let's take a look. If you say we had enough, we had enough. If you want to continue, we can. If you want to choose a different problem, we can. Do we want to choose another problem, or we continue with something else? So that's all I can ask from this section, for you to find the equilibrium point and the consumer surplus and producer surplus. That's it. Should we continue? What do you think? Do you think we need more examples? If you say yes, please choose. If you say no, we'll continue with 5.7. Any preference, anything, anyone? Please say something.
We can continue.
Okay, so the last section of chapter 5 is 5.7. I would say that this section 5.7 is maybe the most sophisticated one. Oh, I'm sorry, let me stop sharing. Sophisticated in the sense that it's a little bit more complex. I'm going to try to make it as simple as possible. It's entitled Differential Equations. Differential equations. What is a differential equation? I said last time, it's an equation that has, so normally we abbreviate differential equations, dE. So AD is an equation that has derivatives in it. We need to solve for y, for the function. And we start with a very simple type of problem. Where is my page? Okay, here it is. Okay, I have the book here. I just need the page for 5.7. Okay, so if I just say 535. So where's my keyboard? 535. Okay, so find the general solution and the particular solution for the given initial condition. I'm not going to start with this. I want to start with something even easier. Something like this. 9 through 12. And then we'll come back to this, of course. Show, let's start with number 9. And then you choose the next one. Y equals x natural log x minus 5x plus 7. They say, show that this function is a solution of this equation. What is this equation about? The second derivative of function y minus 1 over x equals 0. So in this problem, we're not asked to solve. We are given the solution. And they're saying to us, show that this is a solution of this equation. In order to show that, there is nothing I can do to 1 over x, but I have to find the second derivative of y. So that's my starting point. But in order to find the second derivative, what do I have to find first? So I'm given this function, and I need to find the second derivative. What do I have to find first?
The first.
Exactly, of course. I can jump from, excellent, very good. So let's find y prime first. Careful, because I need to use what rule here? What differentiation rule I have to use here? What is it called?
Absolute value.
You mean product,
Oh,
right? It's x multiplied by natural log. So I have to use the product rule. Good. First function prime. How much is x prime? I know, 1. Very good. Times natural log x plus x times, when I differentiate natural log x, what do I get?
1 over x.
Excellent. Minus 5x prime. What do I write?
5.
That's it. And 7 prime is 0. These two go away, 1 and 1. So I have 1 minus 5. So natural log x minus 4. This is y prime. I cannot plug in y prime. I have to find y double prime. Okay, very good. So the second derivative, can anyone differentiate this for us? Natural log x prime is
1 over x.
1 over x. Negative 4 prime, 0. So now I plug this in. Is 1 over x minus 1 over x, is it 0?
Yes.
Yes. So I will say yes. This function is a solution of the given differential equation. Why is this a differential equation? Because it has derivatives in it. At least one. In this case, it has the second derivative. That's why this is a differential equation. So we're not asked to solve. We are only asked, is this show that this is a solution? It is. Once I determine the second derivative, I got 1 over x, subtract 1 over x from the equation, and I do get 0. So I'll say, yes, this is a solution. Good. Let's choose another. What about 13? Well, let's choose A, B, or C. We don't have to go into constants and parameters. I'm happy with one of these, A or B. So if we look at 13, which one would you like to work on? A or B? So the given equation is the second derivative of y minus 7 times the first derivative of y minus 44 times the function equals 0. This is a differential equation. So which one would you like to work on? A or B?
A.
B. Very good. So we are given y equals e to negative 4x. Okay, so this is the same question as before. I just want us to practice with one more. Is this a differential equation? Yes. It has derivatives in it. In this case, it has the first derivative and also the second derivative. We are given the function. The function is e to negative 4x. I will be replacing this here. But I also need to replace the first derivative, and I also need to replace the second derivative. I have to determine them. So for this function, let's find y prime. How do I differentiate e to negative 4x? What do I write? E to negative 4x. Please give it a try. It's okay if you're wrong. I'll correct it. So how do we differentiate e to a function prime? So e to a function prime is okay, let me refresh your memory. It's e to f times f prime. So this is e to f times f prime. What is the derivative of this function?
-4.
That's it. Awesome. In other words, this is negative 4 e to negative 4x. Perfect. So now we have this will be replaced by negative 4 e to negative 4x. We have one more piece, which is the second derivative. I copy negative 4, and I differentiate this again, which is the same thing. E to negative 4x times the inner function prime. Negative 4 times negative 4 is 16 e to negative 4x. So I have this piece now, which is 16 e to negative 4x. Now I put everything together and see if I get 0. If I don't get 0, then I'll say, uh-oh, nope, nope, not a solution. If I do get 0, I'll say, yes, it's a solution. So let's see what we get. So second derivative, 16 e to negative 4x minus 7 times negative 4 e to negative 4x, and then minus 44 e to negative 4x. Since I wrote over it, it was minus, right? Let me look again just to make sure. Yes, it was minus. Good. So the second derivative, 16 e to negative 4x minus 7 times negative 7 e to negative 4x minus 44 e to negative 4x. Okay, let's see what we get. So 16 e to negative 4x. Negative 7 times negative 4 is positive 28 e to negative 4x. And then minus 44 e to negative 4x. Is 16 plus 24 44? So 6 plus 28. So 4 44. This plus this minus this is indeed 0. 16 apples plus 28 apples, I got 44. 44 minus 44 is 0. Then I'll go back and I'll say very clearly, yes, this function is a solution of this equation, a differential equation that was given to us. So this solution works. Okay. Now let's go back to the first type of problem. This was a warm-up. So we know now if we are given an equation and we are a differential equation and we are given a solution, we know how to check if the solution works. Okay. Now find the general solution and then a particular solution for the given initial condition. These are fancy words, but not a big deal. So let's choose a problem from 1 to 6 and I'll explain what we are doing here. Anyone would like to choose from 1 through 6? So this is a second type of problem. The first one was check. Does it work? Yes or no? Anyone would like to pick?
3.
Okay, very good. So let's start with 3. We are given y prime equals e to 4x minus x plus 2. And we are told also that whenever x is 0, when x is 0, the y or function or f of x or y is 4. Okay. We know what this means. I'll refresh your memory in a moment. So forget about the initial condition for a moment. So we're given y prime. We're asked to find y. We've done this before. Whenever we try to find the antiderivative. So this is basically a review of what we knew. So I need to find a function whose derivative is this. Anyone remembers how we do that? For e to 4x, which function I differentiate to get e to 4x? I'm not differentiating e to 4x. No, I need another function that I differentiate to get e to 4x. Anyone, please. It's okay if you're wrong. So remember what we did. It was e to 4x divided by 4. How come? Well, when I differentiate e to 4x, I get e to 4x times 4. And the two 4's go away, and I get this. Minus. Which function I differentiate to get x? That we remember for sure.
X squared over 2.
Excellent. Plus, which function I differentiate to get 2?
2x.
Excellent. And always remember plus a constant c, because the constant prime is 0. There is always a 0 in there. Silent, but there is. Okay, then what is this for? So when x is 0, y is 4. Okay, so 4 equals e to 0 is 1, 1/4. This is 0, and plus c. So then C is 4 minus 1/4. 16 minus 1. C equals 15/4. So there is nothing different than what we determined in chapter 4. We are given the derivative. We're asked to find the function. I will copy everything, but I will replace C by 15/4. We've done this before in chapter 4. No different. So y equals e to 4x over 4 minus x squared over 2 plus 2x plus 15/4. This is it. This is called initial condition. Nothing, so this is chapter 4. No news here. However, let's take a look and see if we want to practice with another one. If you say yes, then let's choose another one.